Tonight's lesson is on subtracting numbers in scientific notation. So hopefully by the end of tonight's lesson, you'll be comfortable subtracting numbers written in scientific notation when given real-world problems and scenarios. Remember, there's two parts to numbers written in scientific notation. You have your powers of 10, and you have your coefficients or your first factors. When we subtract numbers in scientific notation, we first have to make sure that the power of 10 is the same for both, so that you have the same exponent on the tens. And you'll notice in this example, the exponent on the tens is 4 for each of these. At that point, you simply subtract the coefficients or the first factors, and you just write your answer with that same power of 10. So 6 minus 2 is 4. We have 10 to the fourth power, so it stays times 10 to the fourth power. We can check our work by writing out our numbers in standard form. So we could take 6 times 10 to the fourth, and we know if we start with our decimal point right after that 6, and we move it 1, 2, 3, 4 to the right, we actually have 60,000. If you take 2 times 10 to the fourth, and again, you move that decimal point 1, 2, 3, 4 places to the right, you have 20,000. And 60,000 minus 20,000 is 40,000. Let's just double check that 4 times 10 to the fourth really is 40,000. So again, we just take our decimal point after that 4, we move it 1, 2, 3, 4 to the right. Yes, that is totally 40,000, so it works. So the question is, does 60,000 minus 20,000 equal 40,000? It sure does. Therefore, 6 times 10 to the fourth minus 2 times 10 to the fourth really does equal 4 times 10 to the fourth. What if the numbers written in scientific notation do not have the same power of 10? We can look at this example. A dust mite has a length of 2.5 times 10 to the negative 4 meters. A beetle has a length of 3.1 times 10 to the negative 3 meters. How much longer is the length of the beetle compared to the dust mite? First thing you need to notice is that the powers on the 10 are different, and they have to be the same. You can't have one power of 10 be negative 4 while the other power of 10 is negative 3. They must match. And you'll also remember when we move the decimal point to the right, we subtract powers of 10. When we move the decimal point to the left, we add powers of 10. You remember LA, left add. That's your easy way to remember. So the first thing we're going to look at is taking 3.1 times 10 to the negative third and subtracting off 2.5 times 10 to the negative fourth. Well, the first thing you need to do is you need to get your powers of 10 to match. So you've got to take your 2.5, move the decimal point 1 to the left, moving 1 to the left, LA, left add, means we're going to add 1 to that negative 4. And there we show it. So that way we have the numbers 3.1 times 10 to the negative third minus 0.25 times 10 to the negative third. And what you can do at that point is simply subtract those coefficients. 3.1 minus 0.25. 10 minus 5 is 5. We borrowed from there. Borrow from the 3, make the 3 a 2. 10 minus 2 is 8. So then we get 2.85. So if we have 2.85 as our first factor, we know our second factor is going to be 10 times 10 to the negative 3. So there we have it. 2.85 times 10 to the negative 3 meters longer is your beetle over the dust mite. Again, to check to be sure, you could always write 3.1 times 10 to the negative 3 as 0.0031. 2.5 times 10 to the negative 4 is 0.00025. Subtract those, get 0.0028. And in scientific notation, that would be 2.85 times 10 to the negative 3. Mrs. Pearson always says, when in doubt, write it out. So that's what she would do to check herself. Let's practice. Remember, the answers must be in scientific notation. So these are 3 examples I'd like you to pause the video and try out, see if you can handle, and then come on back. Okay, so hopefully you paused the video. What I'd like to go through with you is these few quick examples. It's easier to increase the power on the tens to have them match. We just find that's a little bit easier. So what I'm going to do is I'm going to take this, what I'm subtracting off, I'm going to move this decimal point 1 to the left add, that means I'm going to add 1 to the 2. My whole point in that is so in the end I can have matching powers on 10. So this is 6.7 times 10 to the third minus 0.12 times 10 to the third. And at that point, you just do your 6.7 minus 0.12. 10 minus 2 is 8. 7 becomes 6. 6 minus 1 is 5. Keep my decimal point. So my answer is 6.58 times 10 to the third. In the next example, again, it's just easier to increase your power on 10. So what that's always meaning is you take this one, this 5.2, and again, we're going to move it 1 to the left. So we're going to add 1 to that negative 3 so that now our exponents will match and be a negative 2. Then off to the side, you just do your 7.25 minus your 0.52. Once you've moved that decimal point, 5 minus 2 is 3. We're going to borrow from the 7, make the 7 a 6. That's a 12. 12 minus 5 is 7. And so we have 6.73. So our answer is going to be 6.73 times 10 to the negative 2 power. The whole point was to rewrite so the powers on 10 would be the same. And I'm pretty pleased with that because they're already in scientific notation. I don't even have to do any rewrites. Let's see if the next one needs a rewrite. On average, Mercury is about 57 million kilometers from the sun, whereas Neptune is about 4.5 times 10 to the 9th kilometers from the sun. What is the difference between Mercury's and Neptune's distance from the sun? So the first thing I'm going to do is I'm going to see what I need to do to get the exponent on 10 to be a 9 for this one. So I'm going to move this 1, 2, 3, 4, 5, 6, 7, 8, 9 places over. And I know that that first number then is 0.057 times 10 to the 9th. And so I'm going to take my 4.5 times 10 to the 9th and simply subtract off that 0.057 times 10 to the 9th. Because my powers on 10 agree, all I need to do is 4.5 minus 0.057. So I need to put in a couple of zeros there. So I need to borrow. We'll make that a 4. We'll make that a 9. Make that a 10. 10 minus 7 is 3. 9 minus 5 is 4. 4 minus 0 is 4. So this answer is 4.443 times 10 to the 9th. 4.443 times 10 to the 9th. You got really lucky. Miss Pearson made this PowerPoint for you, and she was a nice person. She didn't give you problems where you had to then rewrite your final answer in in scientific notation. She gave all problems where the answers would end up in scientific notation. That was so nice of her. Focus questions. What are the most important factors when subtracting numbers in scientific notation? Hopefully you do a nice write-up on that. Try to have a good night. Take